Hello and welcome back everyone. Welcome to this new series on deep learning projects, and this time I'm back with a convolutional neural network project. In this particular project we are going to be dealing with a real world dataset, thousands of images of cats and dogs, so that and all those images, by the way, are of different sizes and different colors and taken on a different angle and orientation and stuff like that, so that we can see how we can pre-process the data before we feed to the neural network. Now this is a very important aspect that you'd not usually encounter if you're trying to learn the neural network and how to design the neural network, because most of the tutorial that you will see is actually based on some of the inbuilt dataset, just like MNIC and CFA dataset. Not gonna lie, I have also taken those those kind of projects as well, and I've led those projects a bunch of time. But this time things are going to be rather different. We are going to be dealing with a real world dataset, and where we'll have a bunch of images of varying width and height, and obviously the orientation and rotation and all those stuff we'll be covering as well. And we'll perform some of the transformation, how to pre-process the image and apply some transformation before we feed to the neural network. So there will be a bunch of series of video that I'm going to be uploading as a part of this particular series. I don't know at this point really that how many videos would be there. I'll try to keep videos as limited, as limited duration as possible, but I'll try to cover as much as possible as well. I know it's going to be a lengthy project, I think, and you'd require kind of a dedicated period of time to kind of follow along with me. Feel free to ask me any question in the comment section. Just know that some of the things are very subjective, things like file path, that is dependent on you, because I'm not looking at your computer. I don't know what the file path is and all that. So please spend time on those aspects well, because again that is the foundational part that you'll have to deal with on your own. Apart from that, feel free to ask me any question that you'd want to, and I will be always available here to help you out. I hope you enjoyed this particular series. I'll see you on the other side. So in this particular part, we are going to be focusing on loading real image data and applying this transformation. And later on, we'll actually train the model, perhaps in the next video. But before that, we are going to load it and apply some transformation to augment our data. Now, let us go ahead and jump to our Jupyter notebook here. I have already created this folder in one of my drive. And here you can see here that I have created this CNN project dogs cats. And under that, we have this folder that is cats_dogs. Now, this is the data that I will be using, and this particular data, it is available to you in the description below. You can get it from there. It is a zip file, so you'll have to unzip it and then just place it in your local system wherever you feel appropriate. However, now let us create a new notebook here, and I'll just quickly rename this as loading data, or you can call this loading and pre-processing data, doesn't matter. But let us import some standard libraries, starting with the torch, which is the main PyTorch library. Then I'll import torch.nn as nn, that imports neural network module. Then I'll import torch.nn.functional as f. This import functional interface for the activation functions. Then I'll say from torch.utils.data import data loader. Now, just to be clear, well, I'll just import one more thing, then I'll come to what I'm trying to say. So I'll say torch vision import transforms. That is going to import the image transformation thing here. This transforms, not transforms. And just to be clear, if you can run this, well and good. But if you are seeing some error that is related to torch vision, the module being not present, basically you do not have a torch vision installed in your system. And for that, what you have to do is basically it's a pip install torch vision, and also pip install um, torch. So these are the two packages or library that you'll have to first install, and then you'll have to import it. I already have installed them, and it is available in your notebook. So or should I say in my system? So I don't have to do that. But so I'm just commenting this out. But just run these two things, and you'll have that imported, and then you can import them just like we have done. Now I'll import few more things here. We'll start with some built-in OS module. So I'll import OS, that is operating system module for file path handling. And then we'll use Pillow from PIL import image. So it import Pillow for opening and manipulating image files. Then I'll say from IPython dot display import display. Now you don't have to actually import this because it is kind of optional, because we are using this pillow library to display the images, but still I'm importing this and we'll see that if it is required or not. However, what you also have to do is we are going to suppress some unnecessary warning just to keep things clean, because all these files, all this library, they are going to give you some unnecessary warnings here. And for that I will say import warnings, and warnings dot filter warnings. By the way, you can press tab on your keyboard to get this kind of recommendation, and then use the arrow and then enter to kind of select any options, and then you'll have ignore here. That is going to ignore all the warnings that you might encounter in the future. Well, now what you're going to do is you'll say with image dot open, and here you'll have to put the uh, the file path of any one image. For example, you can go to this and just check out this data. You can see in this cats and dogs folder, you have two more folder, that is training and test set. Let us open training set, and here in training set you'll have cat and dog. If I just open any of them, if I just open this, it's going to take a while because there are a bunch of images here. So you can see there are a bunch of images. This is the JPG files, and if you just click on this, you'll see it is it is some cat file. Well, never mind this woman here, but you have this cat here, right? Focus on the cat. Now here, you can much more better image here. So we have this cat image for example. Basically these are the folder sorry this these are some of the images that we have in our data sets. Now the point is, however, that I would want to use this location. So for this location, first of all, you have to make sure that you're running this notebook in the same location where your folder is located, right? Please make sure that you are running this notebook in the same location or at the same folder where this folder cats underscore dogs is located. So once you have ensured that, then what you're going to do is you'll say uh, dot dot forward slash, and then you will say cats underscore dogs, that is the name of the folder. Then training or testing set, you can pass in testing set here. I'll say in testing set, I have cat as, as one of the folder, right? And then some image, number, right? Or you can just go back and just copy the path of any of the file as well. That is going to work as well. Doesn't matter, right? Just ensure that you are putting this file here, and then file path here, and say display. If you run this, you'll get hopefully an error. Why? Because of this. How about if I change this to something that I know of, about 7? Well, in that case, I'll have to fix some more things here. This is, I think, is, well, actually, I have to go to this CNN projects and docs underscore cat. So what I'll do is I'll go to this thing and just copy this name here. Okay, well, I'll just simply call this as, CNN projects. Never mind. Right? Why I've done that? Because I would then put this name here and say this is CNN project. Yeah. Hopefully this should work. There you go. It has worked. Again, this is the exact part where most of you will get the error, just like how I've gotten the error. So ensure that you're getting this file path absolutely correctly, right? There should not be any issue, but if you are following just like how I'm doing, this should definitely work for you, right? But if you are using some other location and some other folder name and things like that, then you'll have to just go to that particular image in your Finder if you're using Mac, or My Computer if you're using Windows, or any other operating system as per whatever the system that you're using, and get the file path here, and you just have to paste that file path. Again, please do not put these questions in the comment down below, because I'm not looking on your computer. I do not know what location that you're using and all that. So this is the one thing that where all of us, whoever is watching this video, we are going to differ. So please be absolutely careful about this. Then let us create list of all the file names, and for that we are going to be using, first of all, before that, I'll just put in this file path here, and for that I'll just copy this up to this, right? Copy up to only cats underscore dog as it is, right? Again, I'm not looking at your computer. I don't know what path you have, stored this in. But for me, and if you're following me just like I've done, you should be using the same thing. But if you're using some other location, just get the file path of this particular folder, that is cats underscore dog. Okay, then I'll say I'm initializing an empty list to store all the image file path. And then I'll say that for all the folder, comma, subfolders, comma, file names in os.walk. Now, this is, walk is a method in OS library, and that is going to accept the path that is going to walk through the directory tree, basically. And then I'll say for images, so once you have grabbed the file names, I'll say for each of the image in that file names, I want to iterate through them and say that take that image names, yeah, and append it. Now, if you append this with just image and try to visualize what we have gotten, if I just print here the image names, you will see that I'm getting this bunch of list of all the image names here. All right, now what I'll do is here I've just added this string, right? I've just grabbed that particular string in this file names, and I've just, gotten this. But what I want to do is I want to take the folder here as well. Because if you check the folder, for example, right, I'll print folder here just for you to understand that what we have done. I'll print a folder here. All right, and I'll just, comment this out just to, make our output clean. If you print folder, you'll see that I'm getting all these folders here, right? So cats, dogs, and all that. Now what I'm going to do is I'm going to say that you should copy this folder here and concatenate it with this string by adding this forward slash as well. And if you run this, By the way, I'll just comment this out and remove this comment here. You'll see that you're getting a entire path name, right? You see CNN project, cat stocks and all that, then CNN projects, all that. Great. So now we have gotten this files names here. Again, I've appended the full path of the image to this list. Yeah. Now, just to understand how many images that we have found, that is what we are going to do. And for that, I'm going to create a data frame of image sizes. For that, we have to create a list of that. Now, what I'm going to do here is this. Create a data frame of image sizes. Now, image sizes, what I mean by that is width and height. What is the width of the image and what is the height of the image? Now I'll say image sizes is equal to this. Now, why the image sizes is required, by the way, and why it is important for us, we'll talk about that in the next video when you're trying to when we'll design the neural network. But for now, just understand that image sizes are actually very, very important for us. So I'm initializing this list that is going to register all the image sizes, okay, all the image dimensions. And here this is the rejected as this empty list as well. Then I'll say that for every item in I'm sorry, this has to go in the code cell. Yeah, so for every item in this image names, that is this list here, I'm going to loop through every file path collected, and I'll say try, and I'll say with image dot open and pass in the item as img. So I'm attempting to open the image file using the pillow library. If it is an image, right, I want to take that image, get the size of it, and append this with append this thing sorry put this image size in this list here by appending it. So I'll say image sizes dot append. Yeah, so we are appending the width and height tuple to this list, and then I'll say accept rejected dot append and pass in that particular item. Right, so basically anything which is not a image, it is going to get accumulated in this empty list here. Let us see what we have gotten. So I'll say at the end print f literal images, and in this I'll say length of image sizes. So that is going to tell me that how many images are there, successfully processed image. That is what we are collecting. And I'll also print the rejects. F literal rejects, and that's going to be length rejected. And this is, there you go, and run this. There you go. So you can see here there are this many images, 24998, and there are this many rejects that we have gotten, right? Okay, let me check this one more time. Yeah, so we have gotten the test set and also training set as well. Yeah, so all the images, there are about 25,000 images, beg your pardon. Okay, now what I want to do here is I want to store this in df. I'll say df equal to pd dot data frame. I'm creating a data frame here. Yeah, and I'll say image sizes. I hope you have imported pandas library. Oh, we have not. Let us import that. I'll say import pandas as PD. And few more things that I would like to import here. You know, again, pandas, if you're not aware of already, this is for data manipulation and analysis. And I'll import numpy as the library. That is again for numerical Python library for arrays operation, and also import matplotlib library as well. That is that could be sometimes useful to plot the images. Let us run this. You would get an error here, but what I would like to do basically is just, you know, run this and add a df. Try to visualize this df here, what this is all about. So if you run this, you can see you're getting this image sizes. Now, this is where you have to understand that the 0 is the width of the image, and 1, the column number 1, is the height of all the images. Now, if you take this and try to run df.info, you will see that you're getting 24,998 images here, right? And that is having height and width. So what I would like to do is I'll basically try to get some summary statistics that is going to give me, for example, df 0, grab this particular column and run describe. If you run that, I'll get this for width. Or what you can do is just remove this 0 and just describe as it is. That is going to give me what is the, for example, minimum, maximum, average width and height of all the images. Now, why we are doing that? This actually helps us understand the distribution of image sizes, right? For example, the max size would be about 500 versus 500. Some smaller ones would be around maybe 40 pixels, right? But most image cluster around a reasonable size, about 448 to 375. That is a median. And the mean is this much, about 400 to 350. Okay, now let us perform some transformations. Yeah. So I'll say image dot open here and just pass in any image. Doesn't matter what that image is. So I just want to display one specific image, and for that I'm going to copy just any file path here. Just take this one maybe, right? I'll take this one, and it is coming from a testing set. I'd like to rather take from the training set. So if I just do that, yeah, just grab any one of it, right? I'll grab this one. Yeah. And I'll just come down. And what I'll also do is, just kind of, comment this out as well, because it is unnecessary consuming this space. I'll just comment this print here, right? There you go. And then here, I'll just put that image uh, path. Okay. And this is the image. If you run that and assign this to dog, if you run this, there you go. Well, cat here, not a dog. So this is cat. Okay. And if I just say that print cat dot size, this is going to give me the width and height of this specific image, right? And just to display, once you have assigned this to cat, for example, you can just run cat as it is as well, just to display this. But you can see it is having this output cell. But what you can also do is use this display function is here as well to display the image. Now you can see there's no output cell here basically. Again, if you're not aware of what is the relevance of having an output cell or just printing an image, that is about basic Python. Basically, you can display multiple images in this manner, but there can only be one output cell, and that means that you can only display just one image if you just pass in this variable here. Again, uh, quick sanity check here again, that you are seeing something like about 375 to 500 pixel, and it's a important concept that you'll have to understand later on. That let us do it like this. So I'll say that I'll take this cat here, okay, and just pass in 0 comma 0. Yeah, and if you run that, sorry, not like this, I'll pass in cat dot get pixels, and if you run that, you will get three values here. Now, what is this three value? Well, these are the value of RGB channels: red, green, blue. Now, if you're not aware of it, I just want to give you kind of a glimpse of what this is. Just give me a second. So this is RGB code here. Now, basically, anything, all the images basically in the world, they are a combination of three ingredients. That is red color, blue color, and green color. And that is why you will often find this kind of RGB slider. That tells me that you can use any combination of RGB. How much red do you want? How much green do you want? How much blue do you want? And with the combination of that, you can get a different color. For example, maybe if I put all of them as 0, yeah. So you can see here when I'm putting red 0, green 0, I'm basically saying that all the color that you have is blue. But you put all of them as 0, you will get a black color, right? It's a black color. Similarly, if you put 255 right over here, that means I'm getting a red color. If I put 255 here, I'm getting a combination of red and green, that is a yellow. If I put a combination of red, green, and blue at the highest level, I will get a white. Basically, all the colors here, they are combination of RGB. This is one way to understand this, and then you have hue saturation value as well, which you are not going to get into, but basically this is one another way of getting the same idea. But the point is, all the colors here, you are having this green value, for example, right? You can see, and accordingly, all of them have this some hex code is there. So if you change this thing, you will get a different hex code. Okay, so for all the colors, you can see if I just maneuver around, you can see these values are changing, and you are seeing the resultant color here. Why it is important for us? Because this is telling me that this particular pixel over here, the left corner, it is having this RGB channel. Similarly, maybe if I take this pixel here, which is having a width of 375 maybe, so that would be 374. Okay, and if I run that, this is having this pixel. Okay, so again, this is width, this is height. So if you go there, this is the color that I have. Now, if you want to verify that, feel free to use this. So 195, 189, and 137. So I'll put that 195 here, 189 here, and I think 137 if I remember correctly. There you go. So this is the color that definitely suits with this style color here. Okay, sorry, matches with this style color. So this is basically, this entire image is a combination of RGB code in that particular pixel. Now, how many pixels that you have is what you have to understand, right? But the point is that these are RGB code, which is having the maximum value of maximum value of 255 and minimum value of 0, right? All the values of all the pixels are between 0 and 255, and the combination of RGB is what going to give you a different set of different colors in this entire image.